Hi, our group is EC504 Project Group 6, and our project builds a language checker. The following shows our team members. Our language checker has three functions: spell check, grammar check, and phrase check. We also give the spell correction of the misspelled word. The data structure we use for spell check, we build a class named dictionary and combine the hash map and try data structure in our own class. Why we use that? Because the try and hash map both performs a high efficiency of insertion and search. Here is the time complexity of the try and the speed. For grammar check, we build a class named buildRule based on the n-gram model. And for the phrase, we build the n-gram too, but we use the bigram model. The n-gram model. Why we use that? Because models have been shown to be extremely effective in modeling language data, which is a core component in modern statistical language applications. The algorithm, we use the Demerol Levenson distance for spell correction, and I will introduce more algorithm and data structure we use later. I will introduce the technology we use in our project briefly. Firstly, we use JSoup API for scraping the data and generate the grammar TXT. It is used for training the grammar rule and phrase combination in our project. Second, we use Jackson API for JSON export and input. By doing that, we can export our data structure to grammar rule JSON file and phrase rule JSON file. And if we have it, we can check the grammar rule and phrase combination in a relatively short time of importing the JSON file. The third, we use open source for tagged word with its property, which is part of speech. And then we have the word tagged TXT. We can insert the word along with its property into a data structure we build for spell check. The last one, we use the Google Speech Input API for speech input of the GUI interface. Our language checker is accomplished by two steps: build, train data structure, and check. Let's see the build part. For spell check, the dataset we have named word tag txt is stored word with its property in the word list. And we build a class named dictionary. Let's see the dictionary class. In the class, the root stores the word in the data structure hash map. The key is the character, and the value is a try node. The try node class also has the children, you can see here. And the children is also in the hash map character try node format. Actually, roots works as a tree. Each node in this tree stores a character as its key, and the value is like the subtree, which is connected to the parent character. And for the insert function, we can insert the word with its property into the roots recursively. It's an insert function. For grammar check, we have the dataset grammar txt, and we build the n-gram model. We set n to 3. We first build a class named buildRule. The buildRule has an inner class counter. The map in counter is in the data structure hash map string counter. The working principle is same as the roots of spell check part. N-gram count in the buildRule stores the every n-gram along with its count, which appears in our training. To clarify, we consider the word property, not the word, in the grammar check. After creating the class object, we train the dataset and export the object buildRule to the JSON file, named grammar rule JSON. For phrase check, we have the dataset, same as the grammar check, grammar txt. We build the bigram model and train, then export to phrase JSON. Different from the grammar part, we consider the word combination, not the property combination. After building the data structure and training the dataset, we can do the check part. For spell search, we will search the dictionary recursively. If the word is not in the dictionary, we will calculate the Leventrus distance and set the max error to 2. Then we will get the suggestion word of 4 operations: substitution, insertion, deletion, and transposition. Then, if the suggestion word is in our dictionary and the distance is not larger than 2, we will get the highest occurrence of combination with context. By doing that, we can get the most possible word which is connected to the context using the phrase JSON. For grammar check, we will search the n-gram model and get the frequency and property in our data structure. If the result shows the 3-gram is incorrect, we will highlight the suspicious part. For the first part, we will also search the bigram class and get a frequency and probability. If the phrase is not in our dataset, we will include some combination of property like adjective plus noun to avoid some incorrect correction. Have some feature innovations in our project. First, a property of words included in our data structure, so it improved our accuracy of grammar check. Second, our user interface supports speech input. Third, we will improve the grammar rule JSON file in real time based on the user input. For example, if you type in some cramped grammar combination, we will add 1 to the count of the n-grammed of the JSON file. The fourth, the spelling correction is based on the probability of combination of the context. So we will give the user most possible correction words. The last one, the user interface is easy to use and we will demonstrate it.
Alright, so based on the data structure we built or the algorithm we developed before, we created 3 interfaces, the terminal, GUI, and the Android client. I will demonstrate it now. This is the terminal. You can simply type like this, and the examine file is the file we are going to do the chat on. This is the sentence. The spell check, as you can see, we're going to highlight the misspelled word and correct it. So the grammar check is good, and the following phrase, favorite mine, should be highlighted. And all the detailed instruction we already uploaded to the Bitbucket, so you can always try to download and play with it. Let's move on to the GUI. So we already export our whole project into a executable file. Here that should be easier for you guys to try and have a better sense of what we have done in our project. So let's try the same sentence. The spell check. As you can see, we colored the misspelled word, and that should be easier for you to identify the outlier. The grammar check is good, and the phrase the same as before, highlighted the favorite my player. So our checker also supported the speech to text input. The voice recording will last for 5 seconds, so let's try it now. This is a simple test. Okay, so we can do the spell, grammar, phrase check now as we did as before. Alright, since this is the test file provided by the professor, let's import it now. As you can see, the result is too large to display, so we can export the result to our desktop. Now this is the Android client. We also name our project as Chopper, since the emulator does not support the speech input, so we can only test it on a real device, not here. All the other functions are the same as before. We are going to highlight the suspicious part and correct the misspelled word. So there is a button about its project description, and here is the contact. It's all our group members' information. So if you have any questions, you can feel free to contact us, and all the source code has already uploaded to the Bitbucket. So thanks for your watching. Thank you.